Hello everyone, and welcome to this lightning talk on where I'll try to demystify the Json serialization. My name is Ronald and I'm a senior SD for AWS Game Tech. So if you dove through the O3D source code, you may have found another serialization mechanic called Object Stream. Object Stream has been the predominant streaming system, serialization system for quite some time. It's quite powerful. It supports binary, XML, JSON. And it can be used for both source assets, which are those assets that content creators typically work with, and runtime assets, which are cooked assets that the engine will consume. However, herein lies a problem. See, these are two separate parts of serialization with different purposes and different requirements. And in particular, the runtime has more restrictions. For instance, it has to be really strict. So all types have to match exactly, for instance, because it cannot spend time trying to disambiguate between data or go search for it. It's also very unforgiving. You make one single mistake, the entire file will be rejected. And we have to do this for security purposes, because we want to avoid hacking. However, since these restrictions also apply to the source assets, it becomes hard to write those source assets by hand. And when files like that are hard to write, they're also typically difficult to merge. When they're difficult to merge, companies will set up source control with exclusive locks. And when an exclusive lock, only a single content creator at a time can work with these files. And this has some serious negative impacts on cooperative workflows and becomes a real issue when you're trying to scale up the size of your team. So to illustrate kind of these problems, here's an example of Object Stream. This is the XML version, and what probably stands out most are these weird type IDs. Now imagine you're a content creator and having to remember these exact types. Or these fields here, because these fields can have specific meaning, specific locations, or specific names that you have to remember. And to make it a little bit more difficult, you also have to remember these for different versions, because every field and every line here can have a different version, different combination of fields, etc. So what we wanted to do with the new Json serialization is not focus on two problems at the same time, but just focus on one area, source assets. And it doesn't mean that you cannot use the Json serialization at runtime. You can, and it actually is being used that way. But it meant that whenever we had questions about the design, we answered them from the content creator's point of view. So going back to something like UUIDs, we try to avoid this as much as possible. We also wanted the format to be as minimal as possible, so avoid superfluous data. It's possible to strip out defaults. There's no versioning in there because we don't want to burden content creators with that. Where possible, we pack data together so you get a nice and concise document in front of you. The Json serialization is also very forgiving. So you make small errors, we'll try to correct that. So if you have a JSON field that expects a string, but you accidentally put an integer there, we'll automatically convert that integer to a string for you. If we can't do the automatic error correcting, we will report the error, but we'll continue. And we'll still try to give you an object to work with, so we don't bail on it. Json serialization is also very extendable, not just by offering opportunities to build your own custom serializers, but also extendable in the sense that you can have multiple formats for a single type. So, as an example, the canonical version for a color would be 4 floating point values in an array. But that's kind of sometimes hard to work with, so we also offer options to build a JSON object with RGBA values explicitly called out. Or if you prefer working with values between 0 and 255, that's an option too. So the overall result is something like what you're seeing on screen right now. And I hope you can agree with me that this is a lot easier to read, it's a lot cleaner, and the information is a lot easier to process. This particular example, by the way, is from the enhanced PBR material type, because materials are using the Json serialization. If you want to hear more about that, there was a talk by Chris Santora and Johnny Galloway yesterday called Working with Adam that goes into further details. So with the results that came from this, we were so happy that we started applying it to other places as well. So today you'll see that the scene and FBX settings are using the Json serialization. You also see that the Settings Registry has support for reading documents through the JSON serialization. Script canvas is in the process of moving over. And of course, from the announcement from O3D, you may know that the prefab system is fully using JSON serialization as its fundamental system. Now, the JSON serialization is a near drop-in solution for Object Stream. So in places where Object Stream is used today, it usually only takes a few lines of code to replace it with JSON serialization. However, it's important to point out it's a near drop-in solution. And that's because both serialization mechanics do not share the exact same feature set. You'll see this come by in things like the type support not being equal. So for instance, variant, optional, and any are not supported, which is, by the way, not something that we did because of any technical reasons, but really the output of these three types was not really helpful for content creators, and they found it difficult. So we're still looking for a good way to do that. There's also no support for events or callbacks, but we found in practice that this isn't really an issue. That's because the JSON serialization has a mechanical metadata that allows you to bring in data externally into the JSON serialization besides the obvious document. But it also allows the JSON serialization to collect data and export that later on. So what you typically do for events is JSON serialization would collect the information for an event, and when it's completed, that information will be used to call the events and callbacks later on. There's also no versioning control. Again, we wanted to not burden content creators with having to remember exact versions. However, that does move the responsibility more on engineers. Although, in a lot of cases, the automatic error correcting will solve this problem. But in cases it's not, it's currently required to build your own custom serializer to do type upgrades. But we are looking for ways to improve this in the future. Talking about the future. For serialization in general, we're happy with the solution that we got for source assets. However, we want to take those same principles and apply them to runtime assets as well. And then really focus there on binary serialization alone and get that binary serialization to map as close as possible to the in-memory representation of objects. And that's really to cut down on the time spent on deserialization and try to minimize that as much as possible. We also want to build a central versioning tool, not just for JSON serialization. This will be something that we use for all source assets. But for, say, JSON serialization in particular, this will help remove that need for custom serializers. We also want to build an automated documentation generation system. With that, the JSON serialization will be a lot easier to write because you know through the documentation what you can put in those documents and what type of documents there are. For the JSON serialization in particular, we're looking to add more features over the next few years. One of them that we announced yesterday is the import feature that will allow one JSON document to be incorporated into another JSON document, optionally with a patch applied on top of it. We're also looking to build a generic DOM. Over time, this will mean that the JSON serialization would move to be more of a DOM serialization. And with that, we will be able to support not just JSON, but also XML, YAML, TOML, and other similar formats. Right now, there are still some candidates that we want to move over to JSON serialization in the source assets. So we're looking for opportunities. If you just see a place where that will be helpful, I encourage everybody to just experiment with it and try using the JSON serialization instead of Object Stream and see how you like it. And then finally, the objects that are being generated from the JSON serialization today, a lot of them have been conversions from Object Stream. So there's still data in there that we inherited from that. Things like some IDs that are in there. Particularly the asset ID still uses UUIDs and things like that. So we want to do additional passes over them over time to really clean them up and really deliver on that content creator focused document. Prime candidate that we're looking at right now are prefabs, for instance. So with that, I'll reach the end of this presentation. If you want to discuss streaming, serialization or JSON serialization in particular, I encourage everybody to go to O3D's Discord. It's a great way to stay in touch with the community. If you're looking for me in particular, my name is on the screen. And with that, I hope to see everybody on Discord, and thank you for watching.